Hello everyone, let's continue with lecture 4. We will talk about data types today. I'm your instructor, Ms. Laura Lowe. In lecture 4, we will talk about different types in Python programming, and at the end we also introduce array. Before we talk about data type, we have one thing left from the lecture 3. Why names? Why we have the names to assign the value from the expression. So the names actually help document our code. When we have a complex expression, of course we can just do the calculation. We can read and calculate without using any names. But the result can be difficult to interpret. Remember, when you write the code, yes, you want the programming language to write the code to have the computer to give you the result. But eventually, in the future, who will read those codes? Still human. So if you write a program, you want to revisit, maybe even 1 month later, you don't have any name. Sometimes you forget what you are doing. So the names help document the meaning of the quantity in a program, and the purpose is interpreting the arithmetic, what you are trying to do, what you try to calculate. So that's why when you create a name, it's not just not meaningful. When you choose a name, that will help you to remember and understand what you are doing in the code, just in case you need to read that a year later or a long time. Also, especially in the future, if you need to work a project, even now you work a project with your classmates, sometimes you guys need to discuss your code. Or when you go to work, you need to take a vacation, right? You really don't want to have someone take over your stuff. They don't know what you are doing. So have the meaningful names can help not only you understand, the people need to use your code can easily understand what you are doing. Let's see an example to help you understand better. Why the name? Yeah, actually here we have 40 times 15. Let me explain to you what that's for. Actually, 15 is the minimum wage. Since 2022, we increased our California's minimum wage. So we just say typically everyone work 40 hours a week. So with minimum age, you can get $600. So then we have 52 weeks in a year. So yeah, you kind of can, based on the minimum wage, you know the minimum annually wage will be $31,200. Okay, so if you just write like that, of course you can get the result, but only you understand what are you doing. Okay, so and also one thing is maybe the minimum wage will change. So that's why here, that's represent here. On January 1st, 2022, the minimum wage in California for employee with more than 20 employees, they will increase to hourly wage is $15. Okay, so that's why now you see compare option 1 and option 2. Actually, we're doing the same thing. We try to calculate the minimum annual wage. Okay, but which one you will see better? See here, we know the $15 is California hourly minimum wage. You see, it's very clear. You understand what's that doing. And 40, yeah, that's the hours per week. Then we have 52 hours, 52 weeks in a year. So then we know that every year we have so many hours is weekly hours times how many week in a year. Okay, so if you have those things, don't you think that will be right much better compared to what you have? Okay, so we have 2080 hours a year, and we know so here you can do either way. Now you have so many hours, 2080 hours, you can times 15. Or here you have the weekly wage, then your weekly wage times your So that's compare, the result will be the same. So this one we're using, we have 2080 hours in a year. So then the minimum wage every hours is $15. You got your result. Or you see here 600. You can use 600 times 52. They both got $31,200. Yeah, so that's the reason we want to use the net. Okay, so here is for the 2022. Your minimum wage is $15. Yeah, so maybe 10 years later they changed. Or we changed how many hours we need to work for a week. And also maybe in the future, everyone can get 2 weeks off. So then you have different weeks, working weeks in a year. So if we have the name to define here, easily to programmer to understand. And also we can change to different cases as well. Yeah, so that's we finished lecture 3 while we use the name. Okay, let's start lecture 4. We will talk about the first thing, data types. In data type, we will introduce you numbers and the string. So the numbers just like real life, right? Yeah, we have the whole number, we have the decimal point number. So the Python have 2 real number types. If we only have the whole number, we call that an integer. So the integer for any size. A float number is a number with an optional fractional parts. So decimal actually is calculating or can represent by fraction. So the integer never has a decimal point, and a float always comes with a decimal point. If you don't have the fraction part, they just 0.0. And floats may be printed in the scientific notation. So we see some example on Jupyter Notebook. Yeah, so let's see some example. You see here 10 times 3 because they are all the whole number, both whole number multiplied by each other. So of course you see the result is integer as well. So 10 divided by 3 actually we showed you before because you use the division. Division is what? Yes, division is a fraction. Okay, so here you have the 10 divided by 3 actually is infinitely points. It's 3.3333. Oh, yeah, of course, you see, that's wrong, right? So this one we want to say we have the floating point. They most of time they have 15 bits to represent. And sometimes at the end, the last bit not always correct. So that's the reason the floating point usually will give you enough bits, okay? Because the decimal number will give you like 15 bits, 15 digits on that. So we can make sure the first half always correct. Okay, so sometimes don't rely on everything is correct. Okay, but one thing is 10 divided by 3 plus 10 divided by 3. Sometimes even they were wrong, but at the end they still divide correctly. So maybe we can see this one, maybe they already do the fraction calculation first. So then they do 20 divided by 6. Yeah, I'm not sure. But one thing is this one actually the result will be correct. So this one we want to show you. Also, let me show you one more thing. Okay, I think we show you this one before as well. Yeah, 4 divided by 2. Okay, you can see 4 divided by 2 is 2.0. So this one we can see before we told you division always comes with the float number. But you also can think about division is a fraction. So fraction of course that's the float numbers. Okay, so then continue. How about 10 powered by 3? Okay, yeah, so this one kind of makes sense, right? Because 10 times 10 times 10, integer times integer times integer, so our result is integer. But if this one is 10 power 2.5, that will be square root. Okay, so square root 10 is not perfect square. So then they have the decimal number like that. So this one, because we cannot quickly get the result to know the square root. So we are not sure they are really the last digit, the last bit will be correct. Not like 10 divided by 3, so easy to see. But one thing is, at least we can make sure on at least the first half they are correct. Yeah, like we say, float number, the floating points, they have the limitation how many digits they will have. The reason is we really not necessary. If you need for pi, of course, scientists always try to find all the digits for the pi. But most of the time when we're using a floating number, we don't really care all the 16 bits, 16 digits. So that's why we kind of have a limitation on the floating point. We have only holding about 15 bits. But for the whole number part, the integer part, you can see here, we have 1, 2, 3, 4, 5, 6, 7 power to the 890. You see power. Definitely, you know, this number is super big. Okay, we got the arrow. Let's see what the arrow is. Okay, they say exceeds the limit the limit for the integer digit is 4300. Okay, so they say they tell us can use the set int maxima digit. So under the system package. Okay, so then let's add that. Okay, so they say more than 43. So how about we do 5,000, 50,000. Okay, let's run again. Okay, yeah, so you can see, let me move a little bit. Okay, so you can see, because my screen didn't set. Okay, so you can see the whole thing. And they really big, this integer. Okay, so the integer actually can be much bigger. But earlier, you see, we have the arrow to display. So the display, they say, I think by default, they only have 4300. So if we want to have more digits, you see they can increase more. Okay, so that's the usually the floating point part, we kind of only have 15 to 16 bits. The integer part, actually we can allow to have the bigger size. So how to display in Python, also we can change how many digits you want to display as well. Okay, so this one, so then we continue. Yeah, sometimes you see we can have a big number and with the big decimal point. So we see even we just want to run this one. Okay, we run this one. So they automatically to run to the first 4 digits for you. Okay. So like earlier we say sometimes the final digit, their calculation not always correct. So that's why this one, let's copy over exactly the same thing for the first part. And we have not so many digits. So you can see here we have very long decimal digits, but they are kind of similar value. But the other one have the shorter decimal digit. We see what is the result. Supposedly we are looking for the rest of the digits, right? Okay, but then actually that will be 0. The reason is, like earlier they show you. Okay, so sometimes we holding 15 bits for the decimal point, but since you have whole number part also big, so here they just automatically run to the 4th digit. So when you do the subtraction, actually both of them they run to this value. So that's why when you do the subtraction, they will become 0. Yeah, you can try more number if you want to do that. So here we just want to show you. Just be careful. Mostly the calculation for the whole number part mostly are correct. But sometimes when your decimal point depends on how accurate the decimal point you want, they might not be really exactly correct. The last digit may be something incorrect. So if you want to show so many digits, a lot of time, because this one 6 divided by 4 is 1.5. It just matters about the how many decimal points. So it's meaningless we display like 0.00000 so many. So that's why we use the scientific notation. Okay. So try more value you see. Okay, so then let's go back to see our summary about the limitation for the float values. They have the size limitation. Usually precision is 15 to 16 decimal place. after the arithmetic, the final few decimal place may be wrong.